So as we have these points now, we found the zeros, we found the points, and now what we're going to do is we need to think about an equation. If we took took this first term, I talked about this yesterday. If I took this first term, I got x times x, which would give me x cubed. Okay, what does an x cubed graph look like? It either looks like this going up to the right or the other way, right?
Yeah.
Yep.
This is a positive because all the numbers in front of them are 1. So it's going to go up to the right, right?
Yeah.
So just for a reference, it's going to go, I'm just going to throw dots here. It's going to look something like, I'm just doing something like that, right?
Yeah.
But now we have to figure out our points. You know, and I'm going to put that in a different color. So as we figure out our points here, I'll go with red here. What we need to do is, okay, where do we have to pick points? Okay, here's 0, right? And here's, I believe, 8, correct?
Yeah.
What's halfway between there?
4.
4. Okay, let's put 4 in. Okay, we're going to go right here. I'm just going to write it up here. 4. And then what's 4 plus 5?
9.
9. And 4 minus 8?
4. Negative 4.
Negative 4. So that's going to be a big number, you know? And it's going to be way down here, right? Because if I multiply these out, 4 times negative 4 is a negative 16. Times 9 is a negative 144. You know what I'm saying? Okay, I can't really do that very easily.
Graph that.
But I'm going to go a scale of a negative 10 here. 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20,
Go back to
30.
20s.
40, 44. So I'm going to be down here. I'm going to label, maybe I missed my point a little bit there. So negative 4, I'm going to be right here. And I'm going to label my point. That's going to be 4 and a negative 144. Right down there. I have that point now, right? So now what I need to do is say, okay, and this one's going to be a little less precise. I need to plug in, I should go a little bit higher here. I need to plug in a point between 0 and 5, it looks like, right? And let's just do it, make it easy. I'm going to plug in, you could plug in halfway between there, which is 2.5, correct? And I'll try that, let's see what happens. I'm just going to cross this one off. If I plug in 2.5, I'm going to get 2.5 for x. 2.5 plus 5. I heard somebody say 7.5. And 2.5 minus 8.
6.5. Negative 5.5.
Negative 5.5. Now, again, that gets to be,
Big
did I
number.
miss any values here? 2.5.
Oh, yeah, okay. I see. I added the 0.5.
Oh, I'm plugging in, actually, let's start over. My fault. I messed up there.
Oh no.
We're not plugging in 2.5, we're plugging in a negative 2.5.
Oh, yeah.
So we're going to get a negative 2.5 times a negative 2.5 plus 5 is 2.5.
Yeah.
And then negative 2.5 minus 8 is negative 10.5. And so I need to go on my calculator, if you have it, and say, well, what about is that point 2.5 times 2.5 times 10.5? What is it? Yeah, what, you might get a number here?
No. Yeah. My calculator freaked out on me.
63.
63? Exactly.
Nice. 65.65.
Okay, 63 approximately. Okay, so we're going to go up here and say, okay, well, we're going to go up by tens again. 63 up here. And so I'm going to say, I missed the point again.
I got 65.625.
Okay, so we're going to go up here, and we're going to say this point here is 2.5 and 65.25 or something like that.
I would say 5.625.
65, whatever it is.
It's
You're going to label that, right? There's 2 points. Now, we got this point, we got that, we got the lower point, which is way down here. We still need 2 more points. We need a point way out here, and we need a point way out here, correct? Just kind of get if it goes out a little fast, if it goes out a little slow, what happens? So, right here is negative 5. What's a nice point to plug in?
Negative 6.
Negative 6 is easy to plug in. So let's start here. Negative 6 puts it in, right? Negative 6 plus 5.
Negative 1.
Negative 1. And negative 6 minus 8.
Negative 14.
Negative 14. And even though I'm rolling right close by, 3 negatives are going to make a negative, right?
Yeah.
Even though I'm really close to that 0, you notice that this goes up really fast. I'm up to 84 already. So as I go through here, 84 is going to be right about here. I'm going to go here, put a point, negative 6, and a negative 84. And then I need one more point way out here.
So let's just do
Well, I usually go one more year. This is 8, so I'm going to do 9. So I'm going to put a 9 here and put a 9 in the first one. 9 plus 5 is,
14.
and 9 minus 8 is 1. And now if I do that, I'm going to get 126. So that point's going to be, and I'm going to put it up here, way up here, and this is 9. And you notice I'm labeling all my points as I go through. And so now if I graph my equation out, I can't see the 1 point way down here. I'm going to go up here a little bit here if I can. There we go. So my graph, we kind of knew what our graph was going to look like. We're just going to get our values to scale-wise. Arrows at the end of the scale to get our values. We try 1 point in between, 1 point on both sides of the point, and kind of keep going like that. So it's a little work, yes, it's a little work. It's nothing that you haven't done yet. It's just finding zeros, plotting those points, and just kind of going between those to get points as you go through. This one ends up being big numbers,
Yeah, it does. I really love that.
very large numbers as you go through, and that's okay too. I mean, it doesn't hurt to have large numbers as you go through. Questions on that one?
No. So how many points do we need if it's a graph like that?
What I always say, you're going to have 3 points here, or something on that line on the x-axis, right? I always say 1 point between each x-axis to tell me how high I go. I usually use the middle point. And then 1 on each end to give me a kind of sharpness of the graph.
So like 7 points.
Oh, 7 points. You got depends on how many x-axis points you have. You know, if you have more x-axis points, you might have more points there as you plug them in. You know, and one of the things you want to look at, you know, somebody asks, why do you need points, all that points? Is I need to find my max or min. These are helping me find my max or mins because going back to relating back to the first section here, now I could say from negative 2.5 here to 4, it's decreasing. And then from 4 to infinity, it's increasing, right? And from a negative infinity up to negative 2.5, it's increasing, correct? I can see that very easy. I can tell where my turning points are because I have these now, and kind of keep going like that. Okay, I want you to try number 16. Plot the points for me, please. So we're going to look at this. Looking at the work, what are we asking to do? So we're asking to graph, find the zeros and graph number 16 here. 16 is this, y equals x plus 1, x minus 2, x minus 3. These aren't going to be too bad because the numbers aren't as big this time. So it's kind of nice. The zeros of this is what makes each one of those 0. So here is, this one's going to be, if I set it equal to 0, I'm going to get a 0 of a negative 1, positive 2, and a positive 3.
What did I do wrong? Remember? 16?
16.
like 17 or something.
23 years.
Just a little off.
Now, so now what I'm going to do on here is I'm going to plot those 3 points right away. I'm going to go to -1, put a point. I'm going to put 2, put a point, and I'm going to put 3, put a point. Then again, I got x cubed. You notice here I got x, and x cubed, right? If I multiply that first number together, I'm going to get x cubed. You'll notice all of them are positive, so you know it's going to go up to the right, correct? So we know the shape kind of like last graph. Now, what we need to do is, I always, like I said, I like to pick the middle number. It just works better because that's usually, like I said yesterday, 80% of the time that middle number is the lowest point or the highest point. So now let's start with the right, this side over here. What's halfway between 2 and 3? 2.5 is not too hard. Let's just plug it in. It's nice when it's in factored form too, because it's got 2.5 plus 1 is 3.5. I'm just going to put it over here, 3.5. 2.5 minus 2 is 0.5. And 2.5 minus 3 is, 2.5 minus 3 is close, negative 0.5. So if I take those numbers and multiply them out, 3.5 times point.
Negative 0.875.
And I think there's one negative. So at this point right here, 2.5, I'm at, like Chris said, I'm at a negative 0.875. Am I going very far down?
No.
Not even a negative 1. So if I did my scale here and say, here's negative 1, I'm going to be a little bit above there. At that point, I'm going to be at negative 2.5 and a negative 0.875. So I didn't move very far, but a little bit. Not a lot. The numbers are a little smaller. Now, what's halfways between, if we do this to a -1 to 2, 0.5? Okay, let's go up here. I'm just going to cross, I'm going to do a new case. 0.5 plus 1.
1.5.
1.5. 0.5 minus 2.
Negative 2.5.
No, 0.5 minus 2. Negative 1.5, I believe it is, right? And then 0.5 minus 3 is
Negative 2.5.
negative 2.5. So if I multiply those together, and I think Chris is multiplying for me right now, it's
5.625.
5.625. So it's a little higher. So I'm going to say at 0.5, right here, I'm going to be at 0.5 and 5.625. So I'm a little higher at that point. Now we have this point. We have the point in the middle down. We have the point in the middle up. Now we need 2 more points.
So let's do -2.
So you're saying -2? Okay, we can do -2. And that's not hard enough. Not one more to do. -2 plus 1. -1. We're going to plug it in a -2 here. -2 minus 2. No, -4. -4. And -2 minus 3. -5. So if I multiply those together, they're not hard numbers to multiply together. 5 times 4 is
Negative
20, and times the -1 is a -20. So I'm a little ways down, and so I'm over here, and -2, -20. And then I have to pick one more point. I believe this point was 2, and this point was 3, so I would probably put 4 here. And if I plug in 4 plus 1 is 5. I'm just going to put it over here. 4 minus 2 is 2. Okay, that's nice. Those are easy to multiply together. And 4 minus 3 is 1. So 5 times 2 times 1 is 10. So this was 6, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to put that point up here, and this is for 10, correct? So now I'm going to graph my equation. And I'm going to go up, hit this 0, hit this point, come back down now. On this one, it's not much. Come down a little ways. and then go back up, arrows on both ends, unite your graph. Well, how to work. You always pick that middle point, one on each end, to graph your equation. So, questions on that so far? Step by step. What I think is interesting, this would be, if I was looking at an equation like this, I would look at a couple of options on this. One of the things I noticed here on the previous problem too, you'll notice right here it's really flattened out, and then it speeds up like this, or it goes up really fast. And this could be a problem where it could be talking about, very easily, it would be a model like something falling from the sky. You have maybe a parachute, you're slowing down, you're going so you're slow because the parachute rips, whatever, you hit a current, now you start speeding up faster and going down. You have to figure out how much air resistance, how much time you have. And they do these drills in the military, so how much time do you have before you can pull the next one? Or before you black out? Because they tell you those as you're going through these, how much time do you have. Okay, if you're starting to fall, free fall, and you're free falling after your parachute, you have 3 seconds, 2 seconds to pull your next parachute, or you're going to black out and then you won't have an option. They'll train you in that and say, this is what you have to do. And so these are models that say what happens as you do this. So, and some of it is hitting your terminal velocity. You'll see a graph. Usually when you see a graph like this, it'll speed up, and then it levels off because you've reached your terminal velocity. You can't fall any faster. No, terminal velocity is, you only get fast.
Fastest you can go.
Yeah, you fastest you go. You
When
don't have to
you
read a
fall
graph.
at 9.8
It's like,
feet per second, or whatever.
But after so long, you reach your terminal velocity, you can't fall any faster.
Yeah. We did that in science last year. What was the fastest? Like,
So,
if you wait-
okay. So I mean, that's kind of where some of this stuff, it's all these equations, and they're not making up equations. Nobody goes out and say, okay, let's make up this equation. Most math books are made off of word problems, or made off of real life examples. So this equation could be used somewhere.
How do we know that everything we know isn't wrong?
So improved it. Improved it. When you do it for one case, like we're here, we're doing it for one case. What a lot of times you'll see is we don't plug in numbers anymore. Like you'll see, I'm back on the board here, you'll see Peyton a little bit ago was doing a problem up here, or those guys were doing a problem on the board. When we do plug in numbers like this, it proves it for one case, this set of numbers. And now when they're doing their problems in calculus, everything's not based on numbers anymore. It's based on variables. It says we're going to try this for all numbers. And if we can find a number that doesn't work, then it's proved wrong. And if we could plug it for any variable, and it does work for all variables, then it works for everything. So, I mean, that's kind of where you have to prove. If somebody can come up with an example that proves it wrong somehow, then it works better that way. So, but yeah, all these rules have been proved to work. Now, what happens is, like, what's very difficult, and this is most of these rules, like geometry. What is the area of a square? Area of a square is length times width. But that's the area of a square when you're talking, or a straight line or anything. When you're talking on Earth with the rate of gravity and all this kind of stuff. Now, when they start calculating, when we talk about the moon, or the rate of gravity changes, all those formulas are changing. Everything's changed. And it's all different formulas, and it's a new form of geometry. And that's why when I was going through college, when I took a geometry class, 300 level geometry class, we had to learn like 4 or 5 different kinds of geometry. Not just you guys learned last year or 2 years ago, whatever it was. You learned, it's called Euclidean geometry. That's our basic Earth geometry. And we learned the other ones because somebody has to learn it, because you don't want to say, well, we're going to base anything off Earth geometry if you're doing stuff in space, you're doing stuff in engineering. It doesn't have to be in space, because if you get to higher altitudes, all that geometry changes. Or 102, all the thing changes. And so therefore, it has to be calculated in as you go through. And it's not a big deal if you're off a little bit. Most people think, oh, it's not a big deal. Sometimes it is, and sometimes it isn't. I guess a couple of different things.
it's kind of like working in a skyscraper. If you're off a little bit on the tension, a little bit beam, if it's a big deal.
It depends on the beam, I guess.
Well,
That's one of the main support beams.
if you're walking on it, you might not want it to be off. You know, and the pressure of the gas or anything like that up there. You know, I can't imagine working on those things. You know, and you're like up there and you're doing welding and if you catch yourself on fire or the wind blows the wrong ways and catches your clothes on fire, you're supposed to drop and roll. Well, you're working on a beam. What do you drop and roll? You know, and it's hard. You know, and I know that. My niece married a guy that works at he helped build the Twin City. He helped build the Viking City right now, and his uncle does too. And he's one that did start a fire. How do you get a fire out? You don't. They throw it around, and he's ended up in the hospital for 3 months. And so, but what saved his life was the fact that he looked at the gas gauge of where it started the fire, and he was able to calculate it down so the oxygen level cut the fire out. He ended up with first-degree burns on his arms and his face and everything, but it happens. But he says, and like his comment was, well, I have first-degree burns or I'm dead. What's the better choice? You know, so it is, you know, and some people think you're making a story. I have a lot of people, I know a lot of people, and I do, and he does work on those, he helps those things out, and he said, it's sad, like when he said about the other guy that died at the, Viking City a while back. A lot of that dealt with the construction, taking shortcuts, you know, it's safety, shortcuts, and all that kind of stuff, so. So you're working on, you did yesterday 1 through 33 odd, or 1 through 7, and then, so 1, 6,
7 through 33.
7 through 33 odd. Working with the zeros, talking about multiplicity, talking about standard form again, standard form highest exponent to lowest exponent. Working with the grades. We are gonna, I'm looking at the assignments as we hand it in. I've been trying to correct everything as you go along. And I'm asking you, I'm asking you to stay caught up. You know, and a lot of people are saying, well, can we, this was probably one of your longer assignments, 7 through 33 odd, that was 14 problems, 15 problems. That is a longer assignment that I've been given. You know, I'm not asking you to do a lot, but I ask you to do enough to try to get a basic understanding of it. And because we do need a basic understanding. When you graduate, I mean, maybe I'm worried about something I shouldn't be worried about, but when you graduate, or when you leave here this year, I want you to be able to say, well, if I have to go to college and take this class, right, take another class next year, or whatever you're gonna do, at least I have a little background that at least I can get started with it. You know, and that's the main thing, you know. Maybe you won't be an expert on it, maybe you won't get a D in it, maybe you won't get a C in it. That's not my judgment, that's your judgment, but you do have to put some time to understand. So when I ask you to take notes, when I ask you to do note pages, you know, like the last few note pages, if you've been looking at your grades, I'm gonna put my quizzes. And it's only getting 6 people to hand them in, 7 people to hand them in. For quizzes, that's the easy way to bring your grade up. I'm trying to bring your grades up, you know. And I guess the easy way to put it too is I said, well, can you do something to bring my grade up to a C or not? And I always use the comment, and I said, what percent do you feel like you know? I mean, your grade shows you get 30%. Did you learn 70% to get a C? You know, think about it that way. You know, if you get a C in my class, you're supposed to know 70% of the stuff that you went over. You know, and that's the question I would ask. Do you know 70% of it? Do you know 80% of it to get a B? You know, what percent do you understand as you go through this? Because when you finish this class, that's what a grade tells you. When you go to the next year or go to college, they will look at your grades. Don't get me wrong, they will look at your grade and say, you got to be in college algebra 2. That means you know 80% of stuff that's supposed to be in algebra 2. You know that. That makes sense. You know, so a grade is not just how much extra effort you put in or anything like that. A grade is supposed to tell somebody something. It's supposed to tell you a work ethic. It's supposed to tell you what you know. And so when I look at grades, and I'm going to be working on grades tonight most likely, and I'm going to try to finalize most of my grades for the first quarter coming up here. The quarter's Friday, but most of the stuff we'll do for the rest of this week, 'cause I'm gone Friday, will be on the second quarter. And so I'm gonna start working on that as we go. So what I'd like you to do, on page 5.2, 5.2, section 5.2. It's a little different assignment. You've probably done some of these problems already. You are gonna looking at page 293, 4 through 48 by 4s. And then you're gonna watch video 5.3.
Alright, I thought we were doing today.
So you're ahead of me. One thing you have to look at, 4 through 48 by 4s. If you did yesterday's assignment, 4's already done, take a picture of it, right?
Yeah.
You did, the other ones you're not gonna be done with because we did odds, so you got a few, but you might have a couple done. Here, we did some in class, 16 we just did in class a second ago, so we wrote that down, that's done. So 4 through 48 is only 12 problems, and we already got 2 done. We're down to 10 problems. So, I mean, that's not too bad, and I think we did a couple of the other ones yesterday in class, I'm pretty sure we probably did 8. And I don't know if we did any other ones in class, but we probably did, so we probably only down to a few problems that you took notes yesterday and you assignment today. It should not be as long as it sounds like. But let's get some of these assignments done. I'm gonna really get into the point of, I need to figure out a way, to get you to do the assignments I'm giving you. I need to figure out a way, you know, there's different ways of teaching this class, you know, it can come down to where we can go through the sections, but I need to figure out what's the best, you know, maybe we come into the section and you guys come to the board and you come make a project up and you teach the section too. And I don't think too many wanna do that either. You're gonna work on your assignments, you know, so it's project, it can be project oriented, it can be a lot of different ways, you know, but I want you to get to the point, how do I get you to hand stuff in, and how do I get you to do stuff? So we have to look at that as we go. So let's finish this up. I was gonna have a quiz. We will have a quiz, some quizzes tomorrow. I know we just want to day with about quizzes and stuff like that. So. So let's get this done as we go.
I think we'll turn this off.
Has that been on the whole time?
Yeah.